Today we're going to be talking about Chapter 11, Lesson 7. We are going to talk about problem solving and geometric measurements. Our learning objective is you will use the strategy, use a formula to solve problems involving area, surface area, and volume by choosing a formula and evaluating the formula. Okay, so we have to decide which formula to use and then actually solve it. Our essential question is, how can you use the strategy, use a formula to solve problems involving area, surface area, and volume? Unlock the problem. Shedd Aquarium in Chicago has one of the country's few full-scale animal hospitals linked to an aquarium. One tank for sick fish is a rectangular prism measuring 75 centimeters long, 60 centimeters wide, and 36 centimeters high along the outside. The glass on the tank is 2 centimeters thick. How much water can the tank hold? How much water is needed to fill the tank? So we're going to use the graphic organizer to help you solve the problem. First, what I want you to do is go through and pick out the important information. So I think it's important that it is a rectangular prism. I think it's important that it's 75 centimeters long, 60 centimeters wide, 36 centimeters high. And I also think it's important that it is 2 centimeters thick. We're trying to figure out how much water can the tank hold and how much water is needed to fill the tank. So there's 2 questions. So we need to know that we're going to have 2 answers. Okay. Now, looking down here, to start filling it out, first thing we're going to do is figure out what do I need to find. Okay, so what do I need to find? Okay, so looking at that problem, we know we need to find which measure to use. And we also need to find the amount of water the tank holds. Okay. What information do we need to use? Well, we need to use the dimensions of the tank, which are given. And we also need to use the thickness of the glass. Sorry about my writing. I really am trying. The computer's just not taking it right. But just make sure you're paying attention to what I say, or you'll have to rewind it if you don't know what it says. Okay, so how will I use the information? So first, I will decide which measure to use. Then I will choose a formula I can use to calculate the measure. Finally, I will substitute the values for the variables and I will, I'm not going to scroll down because then I had to erase everything. So then I will evaluate the formula. Okay, so that's the blank down there below on my screen. Okay, so first I will decide which measure to use, then I will choose a formula I can use to calculate the measure. Then finally I will substitute the values for the variables and I will evaluate the formula. Okay, so looking over at solve the problem. That was just from reading the problem. Now we have to solve the problem. So choose the measure that specifies the amount of water that will fill a tank. So if we're thinking about a 3D object, so it's a 3D shape, and we need to fill the whole thing. that is when we use volume. Next, we need to choose an appropriate formula. So we know that for volume, we do volume equals length times width times height. Okay, so next we're going to subtract the width of the glass twice from the length and the width, and once from the height to find the inner dimensions. Okay, now we do that because it says that the sides of the tank, the glass at the sides of the tank is 2 centimeters thick. So we don't want to know, I'm going to have to clear this because I want to show you. So up here, we don't really care what that outside dimension is because that's not going to hold water. Okay, so this part right here, this 2 centimeters, this 2 centimeters all the way around doesn't hold water. Okay, so we need to take that out so that we know what we're actually trying to find. So our formula was volume equals length times width times height. Okay, so to find the length, we need to take that 25 centimeters and we need to subtract 4 centimeters. And the reason we do the 4 centimeters is because, again, if you look at that picture, we're taking, so if we look at that picture, we're taking 2 centimeters off here and 2 centimeters off here. So that's where we're getting those 4 centimeters from. Okay, so 75 minus 4 centimeters is going to be 71 centimeters. Then if we find the width, we're going to take that 60 centimeters and we're going to subtract 4 centimeters, which is 56 centimeters. And then to find the height, we're going to take 36 centimeters and we're subtracting 2 centimeters, which is 34 centimeters. Okay, and the reason we're doing that is because that shape we're looking at does not have a top on it. Okay, the aquarium, the tank for the aquarium has no top, so we're just trying to find out how much to fill, so we're not worried about that top section. Okay, so now we're going to substitute and evaluate. So we're going to take volume equals length, which is now 71, times width, which is now 56, times, so we're going to figure that out first. So 71 times 56. Okay, so I think there's a typo in here. So this, I'm not sure, it should probably in your book too, because it should be 71 times 56 times instead of equals 34. So go ahead and make that correction in your book. And when we multiply that all out, we should get 135,184 centimeters cubed. That is volume, so you have to do centimeters cubed. So the volume of the tank is 135,184 centimeters cubed. Okay, and I'm going to go over to a notebook pad and show you that multiplication. Okay, so 71 times 56, 6 times 1 is 6, maybe. There we go. 6 times 7 is 42. I'm going to put a 0 to hold our place. Not working with the 6 anymore. 5 times 1 is 5. 7 times 5 is 35. Add those up. 6, 5, 6, 7. 3,993. So now we've got to take 3,976 and we're going to multiply that by 34. That is our height. 6 times 4 is 24. 7 times 4 is 28, plus 2 is 30. 4 times 9 is 36, plus 3 is 39. 3. And 4 times 3 is 12, plus 3 is 15. 0 to hold our place value. I am going to go ahead and erase these numbers so that I know what I'm working with. And 3 times 6 is 18. 3 times 7, 21, plus 1 is 22. 3 times 9 is going to be 27, plus 2 is 29. 3 times 3 is 9, and 9 plus 2 is 11. Add those up. 4, 8, 9, 10, 11, 15, 2, 1. Oh, 15, gotta carry my 1. Sorry. Well, that's actually not a 2. That is a 3. So then we get 135,184 centimeters cubed. Again, sorry about the handwriting. Okay, so looking at try another problem. Alexander Graham Bell, the inventor of the telephone, also invented a kite made out of cells shaped like triangular pyramids. A kite is made of triangular pyramid-shaped cells with fabric. Okay, so triangular pyramid-shaped cells covering one face and the base of the pyramid. One face and the base. The face and the base both have heights of 17 3/10 centimeters and side lengths of 20 centimeters. Okay. How much fabric is needed to make one pyramid cell? Okay, so there's the information we're given. Now let's go through and read the problem again and see what do I need to find. Okay, so what do we need to find from this problem? So we need to find which measure to use and the amount of fabric needed. Oops. Which measure to use and amount of fabric needed. Okay. What information do I need to use? Well, they gave us all the dimensions of the pyramid, so we probably need to use the dimensions of the pyramid. Okay. How will I use the information? Okay, so there's a couple different ways that we could use this information, but for example, I would use the information, first I would decide which measure to use. Okay, then I would choose an appropriate formula. And next I would replace variables with values, or also plug in what you know. And I'm going to write the last one over here, but I want you to write yours in that box where it says how I use information. So keep it all in the same box or write it right below. And finally, evaluate the formula. Okay. Next, we are going to solve the problem. Okay, so looking at that, first thing we're going to do is decide what measure to use. Okay, so I'm figuring out I need to find the area because it's talking about the fabric covering. Okay, we're not talking about filling, we're talking about fabric covering. So I'm going to use the measure of area. Next, I'm going to choose an appropriate formula. Well, the face and the base of the pyramid are both triangles, so the formula for the area of a triangle is area equals 1/2 base times height. So I think that's what I'm going to use. So replace the variables with the values. So I have area equals 1/2, and again, that's the plug in what you know part. And the base, it told me that the base and the faces both have heights of 17.3, but then the side length of 20 centimeters. So that side length's what I want to know. So I know that the base of the side is 20, and the height it told me was 17 3/10. Okay, so now I'm going to do 17 3/10 times 2. I'm going to add my 0 on to make that 20, and 3 times 2 is 6, 14, 2, 3, add on my 0, and then I've got to bring it over 1 because of my decimal place, so I got that, and then I have to take 346 divided by 2, because I've got area equals 1/2 of what I just found, which is 346. Sorry if I'm moving too fast. Feel free to rewind this and rewatch it. So that goes in 1 minus 2, 1, 4. That would be 7. Minus 14 is 0. And we have 6, which is 3. So area equals 173. Don't forget to label. And that would be, looking up at the problem, it's talking about centimeters. And we're talking about area, which means we would square the centimeters. Okay, so 173 centimeters is the area of one face. But the problem says each pyramid has one face and the base covered. The base and the face had the same dimensions. That's what the problem tells me. Okay, so if the base and the face have the same dimensions, the area of two triangles, I can just take that 173 times 2, which would give me 6, 4, 1, 346 centimeters squared. Okay, so the formula, area equals 1/2 base times height, matches the information given in the problem with what I wanted to find out. So 346 centimeters squared of fabric is needed. And we knew that area is measured in square units. Okay, so that's asking, explain how you knew which units to use for your answer. Well, we knew the area dealt with square units. If it had been a volume problem, we would have had to use cubic units.